Okay, today on the Woken Way, we're doing 4.5a, which is just an introduction to basic sine and cosine functions and what their graphs actually look like. We could use a normal xy axis to graph these, but instead we just have something like this because it makes life a little easier for us. This is still our x-axis, but because we're dealing with sine and that x right there is representing an angle, your x values are going to be angles. So instead of picking -2, -1, 0, 1, and 2, we're going to actually go ahead and pick some angles. So the easiest angles to graph are these quadrantal ones. These are the easiest ones to evaluate. So for example, if I want to know the sine of 0 degrees, I graph an angle of 0 degrees. I notice that it's a quadrantal, so I go to 1, 0. When we're on the unit circle, sine goes straight with the y, and the y value is 0, so the sine of 0 is 0. You could double check this in your calculator. Alrighty, then the next angle I'm going to pick is pi over 2, so the sine of pi over 2. So I'm going to graph my pi over 2 angle, label it, and that actually equals 1. So this is 1. Then I go to pi, plug it in, sine is the y value, so it's going to be 0. Then I'm going to go back here to 3 pi over 2, or down here, and that is the point 0, -1. Sine is the y value, so it's -1, and then I've come full circle, and then I get 2 pi, which is 0. What's going to happen if I were to keep going, and instead of going to pi over 2, I call it 5 pi over 2, what will happen is I'll get 1, and then when I go to 3 pi, I would get 0, and it would keep repeating these same points right here. Okay, so that's called a periodic function. So sine, cosine, and tangent are periodic functions, meaning they go through one full rotation, and then that rotation just keeps repeating itself and repeating itself. So when I want to graph that, what I'm going to do is these graphs do go negative. So like for example, if I did negative pi over 2 on my diagram, that would be here, and that would be a -1, and I'll show you how to do that in a second. But in the x-axis, because we're chose angles, we're going to label these angles. So this is pi over 2, pi, 3 pi over 2, and 2 pi. And then as I keep going, I'm going to get 5 pi over 2, and then 3 pi, and then 7 pi over 2. And I know that it's 7 pi over 2 because this is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, and so on. And then what I'm going to do is I am going to plot these points. So I'm going to label this 1 and this -1. So these are my outputs, or my y values. So the first point I'm plotting is 0, 0. Then pi over 2, 1. Then pi goes to 0. Then 3 pi over 2 goes to -1. 2 pi is 0. And so once I've gotten those points, it's going to start repeating that pattern again. And just so you can see, if it was negative pi over 2, this point would be right there at -1. So this is what the graph looks like that. And so it's making this wave. These are not V's, they are actually curves, so please make sure you draw them with curves. So now that we get this basic graph, again, we just made a table to get it. We are going to highlight the 5 points that we need to start with any parent sine function. This is the shape that it takes. These can be reflected, they can be stretched, we can have vertical and horizontal transformations, which we'll do tomorrow. But those are the 5 points. That's the shape. It starts at 0 and goes, so it goes x-intercept, maximum, x-intercept, minimum, x-intercept. So what is the domain of this graph? This graph can go on forever, from -infinity to infinity. The range, however, if you notice, this graph is trapped from -1 to 1, and we're doing brackets because it can equal 1. Period, how long does it take for the basic sine graph to go through its one rotation? So from start to finish to get back, it's a period of 2 pi. The symmetry, is it even or odd? So that's an interesting question. So the sine of -x, because that's how we determine symmetry, what does that equal? So I am going to show you guys that this is an odd graph, and I'll show you how in 2 different ways. So first of all, what this little symmetry test is saying is like, what's the sine of pi over 4? We're going to start with the positive one. Sine of pi over 4, we draw our pi over 4. It's a special triangle. We label, we take the y value, so sine of pi over 4 equals √2 over 2. What happens when I take the sine of the opposite angle, which is a symmetry test? Sorry, we're going to make that pi over 4 because we want it to be. So here's where negative pi over 4 is. So negative √2 over 2, √2 over 2, and 1. Sine goes with the y value. It's negative. So what this is saying is, if you want to know the sine of a negative angle, all you have to do is change the sign of sine of a positive angle. So when I mean change the sign, that's positive to negative, and then this is the actual trig function. Okay? Amplitude is the height of the function from the midline. So you can see x equals, y equals 0 is the midline. So the height is going to be the absolute value of 1, which is just 1. So amplitude is always a positive number. Okay? So that is our most basic sine graph right there. So what we're going to do is we're going to flip it over right now before we do example 2 and see how we can change these things just a little bit. So right here, you'll notice that the parent graph, this is like a super big sine graph right here. We're not there yet. We're not going to work with bx plus c or d just yet. We're going to wait till tomorrow to do that. But a sine bx is what we're working with today, and we need to see what's happening. So the number in front, which is the amplitude, is going to stretch or shrink the graph. It's going to affect the y values, that midline, just like the number in front always affects our other graphs. The period, this is something that's kind of different. How fast is it going to go through one full rotation? It's 2 pi divided by the number b for x. So that's our horizontal. It's called a phase shift. Just kidding, that's not a phase shift. That's called the stretching or shrinking in the horizontal direction. We'll do phase shifts right here. That's this right here, but we'll do that. We'll do that tomorrow. So again, we still remember how when we do horizontal transformation, stretching or shrinking, we divide by b. So it's the same thing, but you're dividing 2 pi by b in this case because that's your starting period from your parent graph, and then you're going to divide it to go from there. So let me show you how this works on an actual graph. So first of all, when you have this equation, the number in front is 3, so a is 3, so what's the amplitude? It's the absolute value of that number. You'll see in example 4, a is going to equal -2, but the amplitude is going to be +2. Okay? B, what is the number b for x? You might be thinking, why is she saying that and emphasizing b for x so much? It's because I want you to recognize that b is the number b for x. So we're going to see that it's 2, and our period is going to be 2 pi divided by the absolute value of 2, which is just going to reduce to pi. So because we have these 5 parent points right here, we're going to start at 0 and count out 1, 2, 3, 4 to figure out where our period is going to be on this graph. So we're making these really easy for you and not asking you to scale, which is nice. You're doing your scaling by labeling your x-axis. So here's 0, and I'm going to go out 1, 2, 3, 4, and this is going to be pi. Okay? If that's pi, halfway is pi over 2. If this is halfway, this is pi over 4. To count out my other labels, I'm going to do 1 out of 4, 2 out of 4, 3 out of 4, 4 out of 4, 5 out of 4, 6 out of 4, which can reduce, and 7 pi over 4. Okay? So you definitely need your labels here, and then you need your numbers here, and since the amplitude is 3, I'm going to plug it right there. So now all you have to do is, once you have your axes labeled, is to do your 5 points. So you start at the x-intercept, then you go up to the amplitude or the maximum, back to the x-intercept, down to the down to the amplitude or the minimum, and then back up. And then we'll just keep repeating that pattern. And if you want to finish off, you can call this 2 pi right here. So what I actually have is, this is 1 rotation. So sometimes your textbook asks you to graph 2 rotations. So if it asks you to graph 2 rotations, here's your second rotation. So what I want you guys to see though real quick is what y equals sine of x looks like in comparison to this 3 and this 2 here. So you might be like, this looks almost exactly the same as the graph we just did on the front, except for it's stretched up more. Why aren't we seeing it shrink a little bit? And the reason why you're not seeing it shrink or compress horizontally is because we've scaled our axes differently. So if I were to graph sine of x, this is what it would look like. It would go to 0, 0, but it doesn't come up until its amplitude of 1, until it's at pi over 2. Then it does have an x-intercept. And then at 3 pi over 2, it goes to its minimum. And then at 2 pi, it goes here. So as you can see, sine of x takes from 0 to 2 pi to go through 1 rotation because its period is 2 pi. But how many rotations do I get in if I have a 2 before the x? I get 2 rotations in. Okay? This little mini graph right here is just to remind you that when you do sine, you go x-intercept max, x-intercept min, x-intercept. Okay? You don't have to draw that every time, but as you're drawing cosine and sine together, it's just a quick little check for you. Okay, moving on now to cosine of x. We are going to pick the same points and I'm going to draw that unit circle evaluation thing again. The cosine of 0 will be here. What do you notice about that? Cosine goes with x, so it's 1. Up here, cosine goes with x, so that's 0. Cosine goes with x. Cosine goes with x, and we're back. So what you want to notice about cosine is that it's got the same 5 y values. It's still got the same y values. It's just shifted a little bit over. So when we graph it, 0, we're going to go out 1, 2, 3, 4. So that's 2 pi, pi over 2, 3 pi over 2. And its pattern is different. We're going to label these. It goes maximum x-intercept, minimum x-intercept, maximum. So it looks like that. And I'm just going to graph 1 rotation of it. It can obviously keep going. So let's get some of these characteristics down for cosine of x. The domain is negative infinity to infinity. It does keep going. The range is from -1 to 1. The period is 2 pi. And cosine, let's see if we can answer this question. What kind of symmetry does cosine have? So let's do the same check that we did for sine. So we draw our angle and label our triangle. And the cosine of pi over 4, cosine goes with x, so that's going to be root 2 over 2. And now I'm going to do cosine of negative pi over 4. And I get root 2 over 2, negative root 2 over 2, and 1. And that actually equals the same thing. Cray cray, right? I mean, they're exactly the same. So what that tells us is if you plug in a negative angle, it's the same thing that you would get if you plugged in a positive angle. And if you get the same, it will be even. Just a friendly reminder, that means it has y-axis symmetry. And actually, let's go ahead back up to sine and just conclude that with that it has origin symmetry. So remember, origin symmetry means that if you have a point like this that's positive, positive, then the negative, negative will be on there. You change both signs. And here, if you have, and I'll just get negative pi over 2 on there, the y-axis symmetry says that if you have like a positive and then a positive, your x values will stay the same, but your y values will stay the same. Your x values will change signs, but your y values will be different. And then this one still has the same amplitude. So if you look right here, you go to pi over 2 and the answer is 0, and you get the same thing over here, negative pi over 2. So it has y-axis symmetry. All right, let's get that cosine graph out of the way. And it says, what is A? That's negative 2. So we're going to have a reflection in the x-axis because it's out in front. So the absolute value of negative 2 is 2, so that's its amplitude. Well, this is strange. What's the value b for x? It's going to be pi over 2. So the period is 2 pi divided by the absolute value of pi over 2, which is 2 pi times 2 over pi. When you copy it up, flip, pi's cancel, and you just get 4. So if this is 0, which I'm going to label, I'm going to go out 1, 2, 3, 4 and label my period, which is 4. And then this is easy to label. There's no radians in here because they canceled out. My mini graph is just a friendly reminder that cosine starts at its max, goes to an x-intercept, min, another x-intercept, and then its max. Reflections or shifts. This one has a reflection, reflect about the x-axis. So for this particular one, I am going to use a different colored pen to start. So cosine at its basic one would be right here. Let's label these, always got a label. It would go from here, here, minimum, intercept, max. But so the pi over 2 we already took care of with this right here, but we do need to take care of the reflection and the, we actually did that one a little wrong, right? Because it should be 2 and negative 2. So that would be without the negative 2. You can do this in one step. I just didn't catch that negative 2. So there's our points. All right, and now I'm going to reflect those points. So this is going to get reflected about the x-axis. And you're going to want to make sure you come in with these nice smooth curves. Now sometimes students are like, well, if that is what the graph looks like, how the heck would you impose cosine on it like you did up here? Like I did sine in that. So I'm going to show you guys how to do cosine of x. And it's not really the most fun thing in the world to do. But if this was just cosine x, it's going to start at 1. So it is going to be here. But remember, then it goes to 0 at pi over 2. Well, pi over 2 is the same thing approximately as 3.14 divided by 2, which is approximately 1.57. So on my graph, I'm going to go to slightly bigger than 1.57 and put a point. And then at pi, it goes to -1, and pi is approximately 3.14. So I just go to 3.14 and put a -1. And then 3 pi over 2, which would be what? 6.28. If you double that, oh, I gotta triple it. It's not right. 9.42 divided by 2, which would approximately be 4.5 plus, so 4.71. I don't have my calculator here, but you know, we'll make do. 4.71. So again, all I'm doing is showing you how you can put something that has radians on the same graph with something that doesn't. You just have to remember that pi is the symbol for approximately 3.14. So 4.71 back here, and then last we have 2 pi, which is approximately 6.28. So we're going to be back up to the amplitude at about 6.28. So there's cosine of x on the same graph. So you can see what our equation did right here was it stretched it to 2 and it reflected it and shrunk it to pi over 2. So it took it and squeezed it in a little bit. Alrighty? Okay. Have a good day.